Lastly, then, we have the two relationship tests, so the Pearson's rank order correlation test and the Spearman's rank order test as well. Starting with Pearson's test then. So again, we've got the table on the left and the equation and the workings on the right. So it looks a bit more complicated at a first glance because there's a lot more content to the equation. You have to do a lot more workings out to achieve your final answer, but breaking it down, it's a lot easier than it looks at a first glance. So obviously you've got the participants on the left column of the table, and then you've got X, which is the first set of values, and Y, which is the second set of values. So adding to that, you then have X squared and Y squared, and the final column is X multiplied by Y. In this case, the title has disappeared. There was a title there. But basically X is bicep skinfold caliper scores, and Y is tricep skinfold caliper scores of female British gymnasts. And then obviously highlighted in green is the calculations, so total of X, total of participants, which is N, total of X squared, total of Y squared, and total of X times Y. And then you've also got, just to help me out in the future calculations, the sum of X squared, and then the sum of Y squared. So putting this into the equation then, I'll start by doing 8 multiplied by 538. This is because 8 is N, and 538 is the sum of X times Y. So it's that first part of the equation, and that equals 4,304. And then I'm going to do the other half of that top bit, which is 57 multiplied by 71, as 57 is the sum of X and 71 is the sum of Y, and that results in 4,047. So the top half of the equation is obviously the first bracket minus the second pair of brackets, so that's 4,304 minus 4,074, which equals 230. So that's the top half of the equation complete. And then we move on to the bottom half. So you'll start the bottom half with the first main bracket. So we'll do 8 times 507. So you've got N multiplied by the sum of X squared, which was 507, and that equals 4,056. And then you've also, subtracting from that, you are taking the sum of X squared, and the sum of X squared is 3,249. Therefore, you're going to subtract 3,249 from 4,056 to equal 807. Now, as you can see over that, you've got a square root, so therefore you have to square root the 807 that you've just calculated, and that equals 28.41. Now moving on to the second half of that bottom bit of the equation, so you're going to do 8 times 685, 8 being N, and 685 being the sum of Y squared. And then what you're going to do is you're going to square root that, because obviously there's that square root sign over the top of that. The square root of 5,480 is 74.03. So The next stage of that is 74.03 subtract 5041, because you're subtracting the sum of y squared, and the sum of y squared is 5041. So 74.03 minus 5041 equals minus 4966.97. So the last stage of that is you take the top half and you divide it by the bottom half, but obviously you've got to multiply those two brackets on the bottom first, so the two stages that we've just done. So that would be 28.41 being the first bracket on the bottom half, and minus 4966.97 being the second bracket on the bottom half. So you multiplied 28.41 by minus 4966.97, and that equals minus 141,111.62. And then obviously you do the top half divided by the bottom half. So that would be 230 divided by 141,111.62, the numbers that we just achieved, and that results in a total of 0.0016, which is your final answer for R. The critical value for this test, so the DF would be n minus 2, so 8 minus 2 is 6, so you go along to 6, and the critical value, obviously level of significance is 0.05 for two-tailed test again, and the critical value here is actually 0.7067, and if the calculated value is more than the critical value, there is a significant relationship. That is not the case in here, because 0.0016 is actually a lot less than the critical value, which was 0.7067. Therefore, there is not a significant there's not a significant relationship, between bicep skinfold caliper scores and tricep skinfold caliper scores. So Pearson's rank order correlation coefficient test is used when normal distribution is assumed and you have two paired data sets from the same group of participants. Whereas the other relationship test, which is Spearman's rank order test, that's used when normal distribution is not assumed and you have two paired data sets from the same group of participants. Spearman's rank order test looks a bit easier at first glance. There's a lot less to the equation, and a lot less calculations to make, but it still takes a bit of practice, which is why I'll work through this example as well. So in this case, you've got the static sprint scores and flying sprint scores, and you've got rankings for both of those scores. So you put them in rank order. Well, you give each value a rank, basically. And then you achieve a total. So that's the total rank difference squared, basically. And you've got that's the only total that you need in this instance. So moving on to actually putting the equation and applying it to the table on the left then. So you'll start by doing 6 multiplied by 49. This is because it's always going to be 6 multiplied by the sum of difference squared, and the sum of difference squared was 49. So 6 times 49 was 294. And then moving on from that, then you're going to do 14, which is n, so the number of participants. And then in brackets, you're going to have 196 minus 1, because you have n squared, so 14 squared is 196, minus 1, 196 minus 1 is 195. 14 times 195 equals 2,730. So you've done the bottom half and you've done the top half. Now all that's left to do is divide the top half by the bottom half. So in this case you would do 294, the top half, divided by 2,730, the bottom half, which equals 0.11. So the last step of this equation is to do 1 subtracted by that result, that calculation you've just achieved. Therefore you would do 1 subtract 0.11, which equals 0.89. So your final answer is 0.89. In terms of critical values, so DF in this case for Spearman's rank order test would be n minus 2, much like the other relationship test. So obviously we've got 14 participants here, so 14 minus 2 is 12. So therefore I'm going to go down and look at 12 on here, and then you're comparing that to 0.05 again, as that's the significance value I've used for all of these tests thus far. And the critical value achieved from that is 0.59. And again, so if the calculated value is more than the critical value, there is a significant relationship. And if the critical value is 0.59 and the value we've achieved is 0.89, 0.89 is bigger than 0.59, meaning the calculated value is bigger than the critical value. Therefore, there is a significant relationship between these two scores on the Spearman's rank order test. Now, whilst I've done each of these tests manually, there are certain software, such as Excel, where a lot of these calculations can be done for you. Often there's a functions button for simple values such as the mean value, mode, standard deviation, and you can download toolbars such as descriptive statistics analysis in order to download software that would enable you to do statistical tests as well, such as the t-tests that we'd mentioned. So there is software that would enable you to do this a bit more easily without as much manual calculation. Obviously, after you've done these statistical tests, you would then go on to evaluate your findings, infer outcomes from your statistical results, whether it's in terms of statistical significance or practical significance. You begin to create a conclusion from your results and draw up a conclusion towards your original hypothesis.